This video is an overview of lesson 6.4, which is all about the central limit theorem. These slides are based on slides provided by Pearson to accompany our textbook and then modified by me for our course. So this is the fourth and last section that we will be covering in chapter 6, which is about normal probability distributions. Remember, at the beginning of chapter 6, we started by talking about continuous probability distributions and how they were similar and different from discrete probability distributions, which we discussed in chapter 5. Then we also talked about the standard normal distribution, and that's a normal distribution with a mean of 0 and a standard deviation of 1. And then in 6.2, we looked at real applications of normal distributions. So those were non-standard normal distributions that are very closely related to that standard normal distribution through the use of some conversion formulas. So it turns out if you have a normal distribution and it's not standard, you can sort of make it standard by making some conversions. And then because of the relationship between those standard and non-standard normal distributions, you can find a range of x values corresponding to certain probabilities. And you can also find probabilities corresponding to certain ranges of x values. Then in the last section, we went a little meta, and we stopped thinking about the distributions of the data values themselves in the population, but began thinking about the distributions that we have when we have sample statistics. So we call those distributions sampling distributions, and they discuss the distributions of the sample mean, the sample proportion, the sample variance, sample standard deviation, and so on. And then we talked about biased and unbiased estimators there as well. We said that if the mean of the sampling distribution for a particular sample statistic is equal to the true population parameter that sample statistic is intended to estimate, then we said that that estimator was an unbiased estimator because the expected value of that sample statistic is giving us exactly what we want. Now, if the mean of that distribution turns out to not give you what you want, it doesn't give you that value of the population parameter that is expected, we said that we could still consider that to be an estimator, but it's a biased estimator. And we should definitely keep that in mind when we are looking at various types of estimators. Now in 6.4, that's what we're studying here in these future videos. It's all about the central limit theorem. Now the central limit theorem relates to that sampling distribution of sample means, as we'll see when we look at our first learning outcome. So this is the fourth section in Essentials of Statistics, 6th edition by Mario Triola. It's the last section that we will be covering over normal probability distributions. But again, it relates to that sampling distribution of sample means. So here's the key concept. Basically, we're going to introduce the central limit theorem, and we're going to apply the central limit theorem to solve problems. Specifically, we want to understand what the central limit theorem says and what it does not say. So we're going to focus on that in our first learning outcome. Then we want to know when the central limit theorem applies and how we can apply it. And then we want to know how it can be used with the rare event rule for inferential statistics to compute and then interpret probabilities. So the central limit theorem will allow us to compute some probabilities, some very important probabilities, but that rare event rule will allow us to interpret those results. So we'll put those two pieces together to make conclusions about the results of some statistical analysis. Now here are our learning outcomes from lesson 6.4. First, I'll want you to be able to state the central limit theorem in your own words. Next, we will determine whether a distribution of sample means may be approximated by a normal distribution. Then if that's the case, we will compute probabilities associated with a range of values of sample means. And then lastly, we will apply the central limit theorem and the rare event rule for inferential statistics to compute and interpret low probabilities. So that's the plan. Oh, one more. I forgot about this one. Our fourth learning outcome, is to discuss the finite population correction factor and when we might need to use that correction factor. So that's it for our introduction to lesson 6.4. I'll see you in the next video to discuss the central limit theorem.